Welcome to part 2. We're starting with number 7. So looking at the left side, I know that sine squared plus cosine squared is equal to 1, which means that 1 minus sine squared is equal to cosine squared. And cosine squared is cosine x times cosine x. So I could rewrite this as sine x over cosine x times 1 over cosine x. Sine over cosine is tangent, and 1 over cosine is secant. So that's secant x tangent x. Okay, number 8, we're solving an equation. So I'm going to get the cosine function by itself. So I'll first subtract 5. And then I'll divide both sides by 10. And I get cosine x equals negative 1/2. So when is cosine equal to negative 1/2? Well, looking at our unit circle, cosine is equal to negative 1/2 at 2 pi over 3. Remember, it's the x-coordinate, and 4 pi over 3. Which matches with answer B. Number 9. We'll go ahead and get the tangent terms by themselves by subtracting 3 tangent x. We get 2 equals 2 tangent x. Divide both sides by 2. Tangent x equals 1. So when is tangent equal to 1? Now, although tangent isn't labeled on this, I said that you could add tangent to it. But when tangent's equal to 1, we know that the x and y coordinates are the same, which occurs at pi over 4 and 5 pi over 4. And the answer is A. Okay, number 10. Once again, we're going to go ahead and get the cotangent function by itself. So I'm going to first add 4 to both sides, and then divide both sides by 12, which gives me cotangent squared x equals 1/3. So when I take the square root of both sides, I get cotangent x equals plus or minus the square root of 1/3. Which is plus or minus 1 over radical 3. Or plus or minus radical 3 over 3. Now, you don't have cotangent written on your unit circle. You have tangent. So my recommendation here is just take the reciprocal to find tangent. And so basically you get tangent x equals plus or minus radical 3. So if you looked at your mark unit circle, we know that tangent is equal to plus or minus, or positive or negative radical 3 at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Which matches B. Okay, number 11, we're trying to find all the solutions, which means we're going to have to not just find the solutions between 0 and 2 pi, we're going to need to write an expression that includes all solutions. So here, I'm going to first factor out a sine x. And I get 2 cosine x minus 1 in the parentheses. I'm sorry, it does say in the interval from 0 to 2 pi. I was kind of skipping ahead to other problems. So this will be just like you're used to. So I set each of those equal to 0. That's already solved for sine x. Here I'm going to add 1 to both sides and then divide both sides by 2. So sine is equal to 0 at 0 and pi. And then cosine is equal to 1/2 at pi over 3 and 5 pi over 3. So those are the 4 solutions for number 10. I take that back for number 11. I am not going to do number 12 in this video. I'm not going to put one like that on there. So let's just go ahead and go to number 13. If you want to see that in class, I can show that to you. Okay, so for number 13, notice that I have a cosine and a sine, or actually a sine squared. Since it's really difficult, if we can't factor something out, to have 2 different trig functions, we want to write it as the same trig function. So I'm going to rewrite that as 1 minus cosine squared x. Now I'm going to collect all the terms to one side of the equation. So I'll first subtract 1 from both sides. I get cosine x equals negative cosine squared x. Then I'm going to add cosine squared x to both sides. I get cosine squared x plus cosine x equals 0. So I can factor out cosine x, and I get cosine x plus 1. Okay, Mr. Purcell made a mistake. So, where did Mr. Purcell make a mistake? Do you see it? Or have you seen it for a while? Yes, this should have been 2 times 1 minus cosine squared x. So it becomes 2 minus 2 cosine squared x. So when you get this to one side, you'll get 2 cosine squared x plus cosine x minus 1 equals 0. So when we factor this, we know that we have to have a 2 cosine x and a cosine x. These two numbers need to multiply to negative 1, but when we multiply out, we need a positive cosine, which means you must put the positive one here. 2 cosine times cosine is 2 cosine squared. 2 cosine x times 1 is 2 cosine x minus cosine x minus 1. So now we set each factor equal to 0. Here we'll add 1 to both sides, then divide by 2. And here we'll subtract 1 from both sides. So cosine is equal to 1/2 at pi over 3 and 5 pi over 3. And cosine is equal to negative 1 at x equals pi. Okay, so here it says find all the solutions. That's the problem I was thinking of when I mentioned this before. So we'll get the sine function by itself by subtracting radical 2 over 2. So when on the unit circle is sine equal to negative radical 2 over 2? So looking at it, we see at 5 pi over 4 and 7 pi over 4. So 2x equals 5 pi over 4 plus 2 pi n, and 2x equals 7 pi over 4 plus 2 pi n. So to solve for x, we just have to divide both sides by 2. So for this one, we get 5 pi over 8 plus pi n. And here we get 7 pi over 8 plus pi n. And that matches answer B. That will be it for part 2. Part 3 will start with number 15.